Assalamualaikum warahmatullahi wabarakatuh. Hello student. Now we have topic. We will discuss about Newton-Rahpson methods. Okay. Newton-Rahpson method is an approximation method that uses one starting point and approach it by paying attention to the slope of the curve at that point. A graphic explanation of this method is shown in as follows. I mean this graphic illustration for approximation roots in Newton-Rahpson method. It's assumed that function f(x) is continuous. The idea to calculate root, which is the point of intersection between the axis x with the tangent to the curve at a point x n minus 1, fx n minus 1. And the slope of the curve at that point is the first differential of fx n minus 1, so that the tangent line has the equation as follows: y minus function of x n minus 1 equal to the first differential of fx minus 1 x minus x n minus 1. Next, therefore, the approximation root is obtained by taking y equal to 0, is xn equal to xn minus 1 minus fxn minus 1 divide the first differential xn minus 1. Algorithm Newton-Rahpson, you can see this step. The first input in Indonesia or in bahasa we say masukkan. Okay, this is input function continue fx or and f first differential fx, and initial guess x0, maximum iteration and an element n, and accurate tolerance epsilon. Example, epsilon equal to 10 power minus 5. Core calculation when n less than or same with n and error h more than or equal error. We have to count xn equal to xn minus 1 and blah blah blah. You can see this formula, and the final result root xn such that fxn approximate 0, right? And now we are going to the example. Use the Newton-Rahpson to solve x power 2 minus 3 equal to 0 with initial guess x0 1.5. Okay, our solve for this example, because fx equal to x power 2 minus 3, the first differential of fx equal to 2x and the formula for finding the root is from this. And with this formula, we will do iteration one by one. The first iteration, you can substitute that our initial guess is x0 1.5. 1.5 we substitute to this formula and we get x1 is 1.75 and error 1 or the first error is 14.2857 and the same method for the next iteration. Okay, and we know that to the third iteration we have a smaller error, only 0.005314.3%. Okay, and the fourth iteration we have 0% for error. So in the fourth iteration, we get approximate x 1.73205. The Newton-Rahpson method is an example of the fixed point iteration xn equal to gxn minus 1, where a function of iteration is this. And we get first differential of gxs like this formula, and keep in mind that fxs equal to 0 and fxs is not equal to 0. This result that Newton method is convergent faster than linearly. In fact, on absolute xs minus xn less than c absolute xs minus xn minus 1 power 2 is quadratic convergent. Okay, I think that's all for Newton-Rahpson iteration. And your assignment for this topic, you have to solve the function if x power 2 minus 3 equal to 0, which the initial guess x0 is 0.5. Remember, in your assignment, the initial guess x0 is equal to 0.5, and you have to get the solution like the example. Okay, student, I hope you can do your assignment, and thank you. See you next time. Assalamualaikum warahmatullahi wabarakatuh. Bye-bye.